Alright, good evening everyone. In this video, I'm trying to guide you on how you should do your ground beam calculations. First of all, I want you to notice where is your ground beam according to the pembahagian lah. eh. And I want you to mark your beam respectively like this lah. Bagian mana yang korang buat. So, for excavations, for excavation, we are going to use M3 lah. So we need to find the volume, and the volume for excavations is the same with concreting work. So if you are able to find the excavation volume, later on you only need to change the title to concreting work lah. So let's do an example how you should calculate the excavations volume. So take a notice of these symbols here. It means cross sections. So this one's mean cross sections number 1. So you look at 1-to-1 cross sections. So this is your height of your beam. This is your how you call it, thickness or width, but this is usually we call it the height, and then this is the width or thickness lah. So later on, when you calculate the excavations, you just draw like this, this, put in the bank, which is 4,000, and 600 here, and 250 here. Multiply all these measurements, and you'll get the volume. And the next part is going to be calculating the antithermite. So for antithermite, because you have your ground beam, what do you call it, shapes like here, we are going to have three surface that's going to be applied with antithermite. 1 here, 2 here, and 3 here. So we use the same beam sections for. So you have 2 sides with the same area, 1 equal to 2, and there's another side, 3, number 3. So if you are able to get the area for applying antithermite, you also get the area for formwork. So formwork, you do not need to count area for number 3. You only need the area of number 1 to number 2. So just copy paste your antithermite calculations, but exclude number 3 for formwork. Now come to the hard part, the reinforcement. So reinforcement is pretty hard. To me, it's really hard to. So let's try this one. So I want you to take a note about the lapping first. So we have length here. I want you to take note about the lapping and where is the lapping. So for example, the reinforcement bar right here on the top, we call it as top reinforcement bar. We are going to have from here 4,500 plus width. You have again you have 3D 3D here, 3D plus with 3D and plus with you have 4500 here, and then you add 46, oh my god, the 4600, 46 7 4600, 74 600, no actually 746. Oh my god, why is this going on? Okay, 746, because 4500 plus with 746, and then plus another 750, and you got to the point here, and then you plus with 600, and then you plus with 0.42d. So 0.242d is the length of the reinforcement, or you do not have to calculate that one lah, because apparently band right here the band right here is for the top reinforcement right here. So in case the band right here instead of here, you need to add with 0.42d. So be cautious lah, because sometimes the reinforcement bar is not the same on the top at one beam to another beam. Like mine, it's different, 20 and suddenly here 25. So take note, take cautious about the type of bar. So the length of the beam here is 4500 plus with 3D, and I forgot to mention the lapping. The lapping here, the lapping here is going to be 300, going to be minimum 300s. So if your lapping is like this, it is 300. So plus 300 here, plus with 3D here, plus with 4500, plus with 746, plus with 750, plus with 600 here. So that is the length for the bar right here. So for the other one, also using H16, the length is of course 300. 300 plus with 3D plus with 4000 plus with 3500 plus with the length here 704 and plus with 750 plus with 205 2050, but we need to right here, right, to 2050, and then we add with 0.42d because we have band here. So 2500 is this straight length from here, but since we have a band here, so we just add 42d. So let me rewrite the length for this particular top rebar. 300 plus 3D plus 1400 plus with 3500 plus with 704 plus with 750 plus with 2050 plus with 0.42D, and you get the length for the top rebar at the left side. So alright, that's for the top rebar. Now we go to the bottom rebar, because you kinda see the bottom rebar is kinda separated right here, it end here, and the how should I say, the method is same actually. You just need to look at your length very carefully. So for this particular part, it is 3D 3D here, 3D plus width lapping 300. I want you to keep that in mind lah. You're still using 3D, and this one is 300. So the other method is just the same lah for the bottom bar, for the left side bottom bar, which is we have 300 times 2, because one 300 here, another one 300 here, plus with 3D times 2, because we have one bend here, another bend here, then we add the length of the other remaining length lah, which is 4000 plus with 3500 plus with 704. That's for the bottom bar right here. Okay. So there's also another bar right here, which is the bar right here. It is using H16, 3 of it actually. So let's take a look at the cross sections. So we start from bigger beam here, and then we merge with another smaller beam here. So let's take a look at the cross section 4. So 1, 2, 3, 4 right here. So from 600 we narrow down to 400 height of ground beam, and we have three nodes of reinforcement here, and the 3 nodes of reinforcement there is actually the reinforcement right here. So before I went to go to any further, this top reinforcement bar, we have calculated it. We have calculated it because our reinforcement bar starts from 1 right here and ending at 5 here. So it ends and end at 5 here, which, and the reinforcement bar are continuous. They are continuous. So we have calculated the top bar, the bottom bar for 1, 2, 2, 3, 3, 5, 5, 6, 6, 7, 7, and 8, 8. The only reinforcement bar that we have not calculated is this part, because uh, this section 4, 4 and 6, 6, because the the bottom bar is located below the top bar of the other beam. So there's there's not going to be any bend with the bar at the bottom here for beam and section 6, 6 and 4, 4. It's just going to be a straight bar, long bar like this. So if you look carefully, it is actually, the length is actually given already, like this, right? The length here 1 3 50. So the length of this rebar here is going to be 350 plus width, no, 350 plus width 750, which is here, and then plus another 350. There's no bending involved, so it's just going to be a straight bar. Just edit the dimensions, and then to find the weight, you multiply it with the kgm then. So that's how you calculate it. It is given, but it is really messy. I'm sorry about that, because of this drawing, it is messy. So after that, you calculate that, basically done. Basically, you are done for this beam from grid number 1 to number 5. Okay, let's move on to the even more complicated beam, and this problem you will see at your own respective pembahagian of the beam lah. It consists there too. So this problem is because of the dimensions of the dimensions lah, to identify the length of the beam. So I'm just going to give you the idea. I'm not going to calculate it for you like before, because to me it's also giving me headache too. So basically, before I start, I want to show you how the reinforcement bar actually work. So the reinforcement bar, as you can see here, it start here lah. So this indicates you have to minus with concrete bar, you have minus with concrete cover, and the beam is extended, right? The beam is extended. So and then because the 2H16, also 2H16s at the end here, and then we have an alien at this middle rebar, and this middle rebar, the length is going to follow the length of your particular beam lah, after minus cc. Okay, ikut or follow respective, follow beam length respectively, but don't forget to minus the concrete cover. There is no bending. So we are done for the top part here. Now the bottom part, it is going to be continuous too. So we are left with this few reinforcement left. So for number 1 to 3, the length also follow respective beam length. I'm not going to write it because to save time lah. Just look, my charger is only 12 right now. So same as number 4, actually same as number 4, only number 4 we have it shaped like this. 1 2 3, bentuk dia macam ini, panjang dia ikut itu beam, and number 4 kita punya shape macam ini. Kita punya shape macam ini, which means we have to plus 3D plus 3D and then plus 300 plus 300, and this one of course lah panjang itu beam. So let's go, belum habis lagi ya. It will be even more for yang reinforcement ini, this one, right? It is complicated. It is complicated a bit because the beam extends from here to here, from there to there. So as I mentioned before, understand and take note and highlight where is your location of beam. So for instance, this is GF9 to GF13, right? So this is the location of it. Why? Because we have two thickness of beams, which is 200 and 250. So it happens to be the beam here, and the beam here is with 250 thickness. So I think I have given you the general idea of how to calculate the length, the beam here, and the length of the reinforcement bar. You still have to plus 3D plus 300, but the length will be, if you want to find the length, you have to take considerations of subtracting the concrete cover, which is 25 here, which is 25 here. So I hope I can give you the general answer.